We have also other PBT options in HydraFLASH, and there are three different modules. It's Olga tab file, it's a freezing point depression predictions, and CO2 frost point. So again, like you have imagine that you have created fluid, you have characterized it, you have tuned it, then you can use that fluid in performing any of these calculations. This Olga is generates an Olga.tab file, which is used in Olga simulation, compositional Olga simulations. You just need to give the fluid and the range of pressures or temperatures, and it generates a tab file for that fluid over that specified ranges of pressures and temperature. This freezing point depression is the depression of the freezing point of water, only water, because of the presence of salt or inhibitors like alcohols or MEG. So if you want to know how much salinity or the presence of the alcohols or glycols decrease the freezing point of water, this is different from hydrate stability. This is a freezing point of water. So if you want to know how much salinity or the presence of THIs, alcohols or glycols affect the freezing point of water, you can use this calculation module. The other one is the CO2 frost point. It predicts the temperature and pressure, where the solid CO2 forms in a CO2 rich fluid. So this is this is very important in CCS calculation. So imagine that you are working with supercritical CO2, and for some reason the low temperature conditions happen, and you want to know what is the CO2 frost point, at which condition the solid CO2 form in the system. Using this calculation, you can predict that condition. So again, in the miscellaneous PVT options, you have the Olga calculation module, which generates a tab file, which is used for compositional Olga simulations. The freezing point depression of water, please remember, it's the freezing point depression of water due to the presence of salt and or inhibitors. And the SLE, solid liquid equilibrium of CO2. So when you want to know at which conditions solid CO2 forms in the system, you can use this calculation module. Another very useful and unique module we have in HydraFLASH, which is not a calculation module, but it's a module, is experimental database. To our knowledge, HydraFLASH is the only PVT software in the market that has actually a very big and massive database for experimental data. Using this module, you can browse our database and have access to many, around 14,000 hydrate dissociation data points. We have been working in HelioBot and HydraFLASH for more than 30 years. So during all these years, we have gathered so many reliable experimental data. And so what you will find in this database is the outcome of all researches on all these 30 years. So every data in this database are reliable data, because sometimes in the literature you may have not very consistent or scattered experimental data. But these data are available in this database. There are reliable experimental data, and there are many of them that are data that we have to tune our model with. And so using this module, you can either, if you know the title or the keyword in a paper, or if you want, if you know the author of the paper or the year, or the components involved in that data in any database, you can search for that. For example, if you're interested to know if there are any experimental data for a system that includes CO2, propane, and nitrogen, you can include the components there. You can take CO2, propane, and nitrogen, and then it will search whether if we have a data that has CO2 or includes CO2, nitrogen, or propane, or has only CO2, nitrogen, and propane. I will show you how you can use this search engine for the experimental database. The other point is that we update this database at least twice a year. So we add more data, not only that this is hydro dissociation data, but other experimental data, other useful experimental data to it. So user will be able to have all these data, the updated database, to at least twice a year. So if you have a valid license and you have a valid maintenance, then you will get the update for this experimental database, and it will be very handful, especially for academic users. We have also other PBT options in HydraFLASH, and there are three different modules. It's Olga tab file, it's a freezing point depression predictions, and CO2 Frost Point. So again, like you have, imagine that you have created fluid, you have characterized it, you have tuned it, then you can use that fluid in performing any of these calculations. This Olga is generates an Olga.tab file, which is used in Olga simulation, compositional Olga simulations. You just need to give the fluid and the range of pressures or temperatures, and it generates a tab file for that fluid over that specified ranges of pressures and temperature. This freezing point depression is the depression of the freezing point of water, only water, because of the presence of salt or inhibitors like alcohols or MEG. So if you want to know how much salinity or the presence of the alcohols or glycols decrease the freezing point of water, this is different from hydrate stability. This is a freezing point of water. So if you want to know how much salinity or the presence of THIs, alcohols or glycols affect the freezing point of water, you can use this calculation module. The other one is the CO2 frost point. It predicts the temperature and pressure, where the solid CO2 forms in a CO2 rich fluid. So this is this is very important in CCS calculation. So imagine that you are working with supercritical CO2, and for some reason the low temperature conditions happen, and you want to know what is the CO2 frost point, at which condition the solid CO2 form in the system. Using this calculation, you can predict that condition. So again, in the miscellaneous PVT options, you have the Olga calculation module, which generates a tab file, which is used for compositional Olga simulations. The freezing point depression of water, please remember, it's the freezing point depression of water due to the presence of salt and or inhibitors. And the SLE, solid liquid equilibrium of CO2. So when you want to know at which conditions solid CO2 forms in the system, you can use this calculation module. Now let's start performing some miscellaneous PVT options we have in HydraFLASH as well. They are quite easy to use and straightforward. The first one is the Olga tab file. It's the version beta. We are working on this and it will be more optimized. So you have two options. First of all, if you want to generate an Olga tab file, first you need to click on it, you need to go to the PBT options, and then you need to choose a natural gas, for example, this one, and then or for example, let's calculate an oil, because oil is easier. Okay, and then the pressure units. Okay, so you have two options here: the manual mesh or the equal interval mesh. So the manual mesh is basically a temperature and pressure set. So you can choose, if you have a range of temperatures and pressures, you can enter as many as temperature and pressure sets you have, and then it will calculate at all those conditions. But if you want equal interval mesh, so you need to specify the ranges. So imagine that a temperature and pressures is like a rectangle, and you are giving the width and the height of that rectangle. So from temperature 5 to 100, and from pressure from, for example, 1 to 5 to 400, the incremental steps of 1, and this is 1. Just be careful that you have around 500 points here and 400 points here. That will be around 500 and 420, will be around too many points. So it's okay, but try to not create it so big. So I do that, and then so when you specify the range, you just need to press run. So it says that for this calculation, we recommend to use SRK equation of state. Please change the active equation to SRK. Okay, so I change it to SRK, and it asks you where you want to save this tab file and what it is the name that you want to choose. For example, reservoir fluid, and I want it to be saved on my desktop, and then I press save. The PBT tab file has now been exported, and this is the tab file that you can enter to the Olga. Okay. Again, for any other fluids, if I change it to 2, the file will be much bigger. So F2, then desktop, and then press save. Definitely change it to number of intervals. So I press number of interval 100, number of interval 100. So that will take a lot longer. So press on yes. Now you can see that I choose to have around 10,000 points, and it takes a little bit longer. You just need to give HydraFLASH some time, and it will do that. So I just want, because this is just for illustration, I just cancel this, and then for 10, so it's 100 grids data, and I press, for example, 5. This is desktop, and press save, and it will calculate everything. And now you can see the tab file here. Okay, so this is the Olga PBT file. The second one is the freezing point. The freezing point, as I explained in the presentation, is calculate the freezing point depression of water due to the presence of salt or other glycose alcohol inhibitors. So it's very straightforward. You just need to choose the fluid. For example, I have this chemical solution. I don't remember what was the composition of this chemical solution. So I go to the fluid management, and I press edit composition. Now this is the composition. Mole really doesn't make sense to me, so I change it to gram. Okay, so it's a solution that 78% of it is water, 20% of it is methanol, and 10% of it is sodium chloride. So I'm happy with it, and I want to know for this solution what will be how much methanol, 20% of methanol and 10% of salt will change the freezing point of water. So I'm happy with it. I just wanted to know what is the composition, so I close this one. At atmospheric pressure, and I just press run. That means that my freezing point depression is actually 31 degrees. So the freezing point of this solution is minus 31. So that means that 20% of methanol and 10% of sodium chloride reduce the freezing point of water by 31 degrees. It's very easy to calculate. So if I want to change, for example, if I want to just see the effect of sodium chloride, this gram, so I have, for example, 85% water and I have 50% of sodium chloride, and I call this chemical solution, or I call this, let's call this brine. I save it as a new okay, so 85, save as new. Okay, no. Okay, so 15% of sodium chloride tells me that reduces the freezing point of water by minus 12 degrees. Okay, so this is a very easy and straightforward calculation module. I'm not going to explain it more. So let's go to the CO2 SLE, the CO2 SLE frost point. If you have a CO2 rich fluid, for example, something like this, CO2, methane and ethane mainly, or nitrogen, so it's 95% CO2, it's 2% methane, and it will be 0.7% ethane and 0.3% nitrogen. Maybe I change this to 1, and I've changed this to 1, so I get 100. So all these are mole percents. So this is my CO2 rich fluid, and I call this CO2 rich. And the natural gas is what is it? It's a CO2 rich fluid. It's not wet, so it's dry. The hydrates, for example, yeah, probably it's not contaminated. So I save this to database. Now I don't want to create another fluid and press no, and I want to know what would be the frost point of CO2 at atmospheric pressure, or maybe low. Let's change it to 100, for example, 50 bar, and it tells you that the frost point of CO2 is minus 58. If I change it to the CPA, minus 58. Okay. Again, you have this option to copy the results, save it to database, export the data to an Excel file. Again, like freezing point is a very straightforward calculation, and it tells you the CO2 frost point for this composition. It's very useful in calculations for CCS, carbon capture and storage calculations, which tells you if you have a solid state, if a leakage or anything, if you have a supercritical CO2 leakage happens, or after a throttling valve, the temperature, goes below a certain degrees, and you want to know if whether CO2, solid CO2 is forming or not. Okay. So the next one is the most important one amongst the PVT option, which is the experimental data. In HydraFLASH, we have an experimental database connected to HydraFLASH. So when you install HydraFLASH, that experimental database will be copied into the installation path, and you will have access to this. This experimental database contains more than 14,000 dissociation data, reliable dissociations that I explained before. It is very useful, and I just wanted to show you how you can search in this database. Okay, so the first one is the you can see that there are many expanding sections or expanders. You can expand them, you can minimize them, you can maximize them. Okay, so what you need to know is that which components you are interested. Okay, so I'm interested in the hydrogen dissociations for CO2 for a system that contains CO2, nitrogen, and H2S, sour gas systems, right? So I take these components. it doesn't really matter what is the title of the paper. So all keywords, which author, all authors. If you know a particular author, please write the name here. But published year, all years. If you are interested in year, for example, the data after 2016 or after 2012, you just need to enter here. But I'm interested in all years. And I have hydro dissociation point. I'm interested in the hydro dissociation point. And this menu is inclusive. So that means that it will show all the data that contains CO2, nitrogen, and H2S. So that will be inclusive. But if I choose only selected, it will only load the data that only has CO2, nitrogen, and H2S. Okay, so I'm interested in this. Let's see if we have any data in HydraFLASH. I press search. Unfortunately, no data was found. Okay, so now I press inclusive. I press search. Okay, so there is no data that it contains CO2, nitrogen, and H2S at the same time. So I press only CO2. Loads of data here. CO2 and nitrogen. Loads of data in here. And if I press, for example, CO2 and nitrogen, only CO2 and nitrogen, I have only two data. For example, I didn't have any data, for example, for CO2, nitrogen, and H2S together. So I have two data for CO2 and nitrogen system. So it's a combination of CO2 and nitrogen. And I want to know, okay, what is the data? You can see the reference number. The published year is 2002. The most recent one is 2012. This is the paper title, and the authors of that paper are written here. You can see them here. And if you want to see what is the data, you can press this button, show the data. We show you the paper title, authors, the journal, year, the volume of that journal, and the pages in that journal regarding to this paper. And then this is the data you have. This aqueous mole fraction, the temperature in Kelvin, and the pressure in megapascal. Okay. Now if I want to see what is this data, okay, so it has been presented by Kang et al. In 2002, and now you can see it shows you the mole fraction of CO2, and you have all these data. You can copy them into an Excel file, you can use them, we can compare the predictions with these example data. Okay, so for example, let me choose another system. For example, I'm interested in the hydro dissociation points of methane, and only selected, and it uses so many data. The most recent one is 2014, I guess. So it's pure methane. I want to show what is this data, and you can see, okay, so this is the data presented by these authors. Okay. And then, as I said, if you have a title, if you have a specific paper in mind, you can write the name here, you can publish the published year and everything. And this is the important thing, and as I mentioned in the presentation, is that we update this database twice a year, and you can, if you have a valid maintenance and license, you can have access to that data as